Welcome, guys. Glad you all came to our meetup. We might have some more people trickle in, and if they do, they're welcome to come. But I'm glad you all made it today in the middle of the summer. In the summer, meetup attendance drops, but the quality of the meetups never declines. I'm Mariah. I organize meetups. Basically means I coordinate with the hosts and the speakers and the internet to make sure that these meetups happen. We are super grateful for Recursion for hosting and providing food and this wonderful space. And they will give me a recording so this can go on YouTube. So everybody give Recursion a round of applause for being fantastic. We appreciate them. This meetup cannot happen if people do not give spaces. So thank you so much for that space. So for announcements, if you have not joined Forge Slack yet, you should. It is a fantastic Slack. Forge Utah is a group of technologists. We host meetups. We talk tech. There's a fantastic hardware channel. Sometimes I'll go and troll the Rust channel or the front end channel. Machine learning channel has been kind of fun because it's just all us complaining about ChatGPT. If you want to join that, you just go to the forgeutah.tech. That website will give you a link to Slack, forgeutah.tech. So now I just want to give a space if anybody's got any job announcements. If anyone's hiring, they'd like to announce that they're hiring, share jobs. Nobody's hiring. Okay, Brian will talk about his during his talk. That is the state of the economy, guys. Cool. And then the last announcement, we will have a meetup in July because we will be sitting right in between our two holidays. July 16th, it will be in Draper at the Forge Utah headquarters, and we'll be doing lightning talks. So if you have ever wanted to share anything in your life, I'll give you a 5-minute theater to talk about it. Hopefully it's tech related. I don't know it because people assume. But does not have to be data engineering specific. It can be adjacent. So if you really like ChatGPT, you can talk about that. Or you can talk about your Node apps, or you could talk about Java. I only cringe at Java because I'm a Go developer. So yeah. And with that, I don't have anything else. So let's turn the time over to Brian. He can introduce himself and give a talk. That means everybody clap for Brian. Thank you. Thank you.
Can you guys hear me with this mic? Cool. All right. We're going to talk about writing unit tests today, which is a super exciting topic. So I'm also going to have a little bonus topic in here where I'm going to tell you about how I've gotten every job and every promotion I've ever gotten. So you have to pay attention to make sure you hear that part. So data engineering is a pretty wide field. So I kind of want to do a quick survey from you guys, kind of get a feel for the area that you're focused on. So raise of hands, who's a coder? Who writes code? Awesome, most of you. Who manages people that write code? A couple of you, awesome. And then who does like database administration or anything? One, okay. Well, we're gonna be talking mostly about code today. So most of you are gonna be, maybe you'll get something out of tonight. So awesome. So quick little intro about me. I'm Brian Broderick. I've been writing code for about 20 years. Currently, I'm a principal engineer at Entrada. Entrada does property management software. We do have an opening there. It's on the database engineering team, which they do a lot of optimizing queries, making sure things are running efficiently. It's less on the administration side, more on SQL and that sort of thing. So if anyone's looking for anything, let me know after and we can chat. I enjoy the outdoors. I enjoy gardening. Lately, I've been re-landscaping my backyard, so that's where all my free time's been. And then I took up a pottery class with my wife, and turned out I thought I was going to hate it, and it turned out I actually like doing it. So we've taken the class a couple times. But throughout my career, there's just been kind of one theme, and that's just I have a thirst for understanding, and that's just been a driving force for me throughout my career. And so always trying to learn something new. This is a fantastic field for that, where there's always something new to learn. And feel free to link to me if you'd like. GitHub linked in there. Cool. So I'm going to be candid with all of you and a little bit vulnerable here. For the first 10 years or so, I didn't write any unit tests. I didn't write any automated tests. I did that because I never really gave them a chance. That's pretty much why. There's a whole bunch of excuses I wrote down. Pretty much the reason why is because I felt like writing tests was going to take time away from writing features. And I couldn't have been more wrong, to be honest, because I always thought it was going to slow me down, and actually it speeds me up by doing this. So now I always test my code. I just didn't do it in a repeatable way. I'd hammer the F5 key. We don't do that as much anymore. We use Postman or something else, right? But my F5 key basically looked like that. And that's how I tested. So there's a few points in my career, and maybe this is something that you identify with, where I would work at a place, wouldn't really learn a whole lot of new, just kind of status quo. But every once in a while, there was a catalyst that really propelled my career forward and made me a better engineer. And one of those catalysts was this guy. I don't know if anyone knows David. He's awesome. He and I worked at a place called Nuvi. Nuvi does or did, they've been bought out, but they did social data analytics, where they were pulling in stuff like Twitter feeds, seeing how far, top 10 hashtags, top 10 mentions, those kind of things for marketing companies mostly. And that's the first time that I really had to focus on and even care about scale in my career. And there, milliseconds mattered. So we were inserting millions of rows a second there. And so just shaving off a little bit of time here and there made a huge difference. But while I was working there with David, he taught me kind of a testing-centric mindset. And that's the first time that I really embraced writing unit tests and integration tests. A little background with him. He worked with a guy named Mike Moore. I don't know if anyone knows him, but at the time we were all writing Ruby code. And in the Ruby community, the main testing framework is called RSpec, or at least used to be. RSpec, honestly, I hated. It was like a lot of things in Ruby, where convention over configuration is a big deal. So if you knew exactly how everything was supposed to be set up, and you followed exactly how they told you to do things, it worked. Didn't work for me. I didn't like it. Mike also didn't like that as much, and he worked with a bunch of people. There's a big Ruby community in Seattle. He worked with some of them to build a new testing framework called Minitest. Minitest is now the Ruby. It's the de facto Ruby testing framework. And it's just a minimal, it doesn't do all that convention over configuration or anything like that. So Mike taught David, David taught me. Maybe I can teach you guys something tonight. So, but honestly, by going from like embracing this mindset, it literally changed everything for me. Prior to that, I was writing a lot of pretty large functions, 200, 300, 400 line functions were common. maybe that resonates with some of you. Maybe that you're like, oh my God, I can't believe that he ever did that, right? But once I started thinking about I need to actually test this thing, it made it so I wrote code differently. I started making my function much smaller because if it's too hard to test, it's doing too much, right? And really, if you remember anything from tonight, just remember this one sentence here. If what your code is doing, if it's too hard to test, it's doing too much, right? There's a concept called the single responsibility principle, which basically says each thing should do one thing well. That one thing, it depends on the scope, right? If it's a microservice, it's going to be a larger scope than a function, but you can have maybe a service that's like a user service or an authentication or something, and that's the one thing that it does, right? And then within that, it maybe there's a module, there's a module to create a user, right? And all that module does is create a user. And instead of that, there's going to be individual functions. Maybe one of them inserts a row or something. And so as long as each thing is doing one thing well, that's the single responsibility principle. And if you adhere to that, it makes your testing so much easier. And it's like the circular effect of you make your code easier to test, your code becomes more discoverable, becomes more maintainable, and so on. So, okay. So there's different kinds of tests. They solve different, they have different purposes for each kind. We'll talk about unit tests first. We'll probably spend the most time on unit tests tonight because they're the most important. I should have made a graphic, but there's a pyramid where your unit test should be on the bottom, where most of your testing should be there, and then it goes from there to integration and so on, right? Unit test specifically, it's a very simple concept. It's basically this. It's you have an expected value of a function, and that's on the right over there, and then on the other side you have what you're trying to get on the actual. So you have some parameters you're passing to a function. It returns something. Does that something equal what you expect? If it does, it passes, right? And that's it. That's really all it is on a unit test. It doesn't have to always be equals. There's a bunch of operators you can use depending on what framework you're using. Greater than, less than, is it null? Is there an error, etc. But that's basically it for unit tests. And so I wrote a function that just converts a word to plural. This happens to be go here. So, at the top I've got, I'm converting person to people and so on. When I wrote the function, I wrote all the different test cases that I could think of, but you're never going to catch everything in that first pass. And so what happened was when I actually ran it against a data set, I ran into a bug. And once I found that bug, I added another assertion at the bottom that matched what the bug was. In this case, it's an invoice validator. And I wrote that assertion in there, and then I went and fixed my code. It finally passed, and I moved on. Your tests are going to grow like this. The more edge cases, the more bugs you find, you're going to keep adding more and more assertions there, so that when you change code in the future and you run this, it's going to still work, right? All the things that you thought about in the past, it's still going to go back and check all those things, right? One very important and kind of controversial thing with unit tests is that you want to mock all of your dependencies. That means you don't run database queries in your unit test. You don't hit Kafka. You don't hit an API. Everything's mocked. You want to scope it as small as possible. And that's basically unit tests. At the end, I do have some code that we could go over. If everyone's still not tired of listening to me at that point. So I can show you a little bit more about actual unit tests that I've used in an application, but this is basically it for unit tests. I'm going to pause there. Does anyone have any thoughts or questions? Yeah, and that'll be the next one. That actually that's a really good segue. So actually, sorry, we got one slide before that segue. So in unit tests, the reason why you don't mock and the reason why you want those to be as small and as fast as possible is because you're going to run those a lot, right? We have in this example, this is a just a toy project of mine, and it happens to be in Go. So Go is running, it's building, and it's running. In this case, is taking 0.2 seconds. The app that I was working with David, it was a Ruby app. Ruby is not the fastest language in the world. We had about 2,000 tests, and it all ran in under a second. And that's kind of the benchmark. If it was running over a second, we started to do things to speed it up or figure out how to run less tests. So in this case, in Go, you can run all the tests in your suite, or you can just drill down into a folder. And in Go, this happens to be all the folders are packages. So I'm running just the tests inside my MQL package. So you can break those tests down into smaller bits so that you can get all the tests that you need under that second. The reason why it's so important there is because, at least for me, I run tests about every line of code I change, really, like, or maybe every couple lines. So I'll change a line, I'll run my test. Okay, it still passes, or it doesn't pass yet, or whatever. I'm going to run that hundreds of times probably by the time I'm happy with either that function or that module or whatever I'm actually trying to test. That's why it's at the bottom of that pyramid, because it's the cheapest, it's the fastest, and it just becomes that feedback cycle of, okay, instead of hitting F5 to see if the thing showed up on my screen, I'm going to run tests and make sure that it passes, right? So now we'll talk about the integration test, and this is where this is answer your question. This is where you actually run. This is where you actually run queries. This is where you actually hit Kafka or the API or whatever, test API. And this is going to be a lot slower because it's actually going and doing, it has to go out, it has to connect, it has to run that query. So I don't run these as often. I might run them a couple times a day, or definitely before I'm going to ship a PR, I'm going to run them all, make sure they work. This is part of the CI/CD pipeline, so that everything passes before I actually ship code. But it's slower, and this is where, like, my guess is you guys probably have testing frameworks where you try to run tests and it takes 40 minutes, right? I got at least one nod. Yeah, that's great for when you're checking against regression tests, but it doesn't help you when you're trying to just write that one function, right? It's just too slow, but it will help against those regression tests. So we had one where somebody added a column on a table, happened to be the same column name as another table. I think it was like deleted at or something like that. They weren't aliasing their tables, and so it broke, right? There wasn't a test in that case, and it caused downtime because they shipped it. It broke. We had to fix it. We had to ship again. So we had a little bit of downtime there, right? It would have been so easy if we had an integration test for that to find that and fix it before we shipped, right? And that's what integrations are really all about, is like, is my query actually working? Did I actually get the data that I expected? And did I break something that I wrote 3 months ago? Here's an example of an integration test. This happens to be in Ruby. 3 lines of code. It's doing a lot, which is great because it means I can write a test super fast. I'm not going to spend really any time writing a test. In this case, I'm getting a specific API endpoint. It's running through the controller, it's getting all the data, it's taking all that data and it's throwing it to a variable called authors. It makes sure that it actually got assigned, and then it returns an HTTP 200. So that's the success there, right? If all that passes, I just probably tested about 2,000 lines of code. Now I could have gone in way more detail. I could have drilled into the authors. I could have looked for specific values, and in a real test, I probably would do that. But I wanted to show you in 3 lines of code how incredibly powerful that is. The problem is it just takes a little bit more time because you're actually running that query, and so you're not going to run it, 100 times in that day. Maybe you're going to run it a couple, right? So that's the difference between unit tests and integration tests. People will also call these feature tests. There's kind of a little bit of a nuance there, but basically they're the same thing. A feature test is more testing a feature. Integration test is more testing the integration between code and a dependency like a database or something. But I mean, that's kind of splitting hairs. It's basically the same thing, right? Does that make sense? Does that answer your question? Awesome. Any other thoughts or questions up to this point? Cool. We'll move on. The next kind of test is a benchmark test. These aren't run as often as I would like. This particular test, I wrote. David and I were kind of betting on which way was faster. So this is all Ruby code. Basically, all it's doing is it's setting an instance variable. But remember when I told you at the beginning that at really nanoseconds matter because we were inserting so much data there. So there's 2 ways to set an instance variable. And we were just like, okay, what way is actually faster? So I wrote a quick loop. I do one way in the top, I do the other way, and then I just time it. And it turns out setting the instance variable using their method happens to be, it came out 0.04. The eval version of it was 0.1, so the eval was 2.5 times slower. We ran this exactly 1 time. We never had to run it again. It was more just a bet to see like who was right, honestly. But like this is an example of a benchmark test, and we learned something, and we went with the instance variable set with the app after that, and we shaved off some time there. So a lot of other benchmark tests will be testing against your database. How fast is your query? Run it a bunch of times, simulate a bunch of users hitting it, those kinds of things. Really, like in my career, that's few and far between when that actually happens. Most people instead, and this is actually a fantastic way to do it too, you'll just log production results, right? You'll send it to something like StatsD, you'll send it to Prometheus or New Relic or whatever, and you'll just be able to see how slow everything is or how fast everything is. Where that doesn't help you is where you're trying to project. So you're like, okay, my database has 1 gigabyte in it today. But what happens in a year when we have a terabyte, right? Getting today's metrics back isn't going to help you there. And you guys are all data people. You probably have seen where the query was running super fast, and then at a certain point, you got too much data, and it just went to hell, right? Maybe you didn't have an index or something. That's usually the de facto way to fix that. But at some point, the database is like, nope, I'm done. I'm going to take 3 seconds instead of a millisecond to do that, right? That's where the benchmark test would help you, is like you're simulating a lot more data. You're like, okay, we have a 6 months runway before we need to go and do something else, right? Or whatever. I haven't really seen that happen a lot. Nice to have that knowledge, right? Any thoughts on benchmark testing? Cool. I don't know if you guys have ever heard this phrase before. The phrase has been around for a long time: make it work, make it right, make it fast. It kind of came back with when Agile started becoming popular. But make it work, make it right, make it fast. It basically is a code quality. Make it work is, okay, I wrote all my code, I hit F5, the word showed up on my screen that I expected, and okay, it works, I'm done, I'm moving on, right? it's, in my opinion, that's hackathon quality or proof of concept quality. It's great for one-off tasks. In that case, you do have acceptance tests. So quick thing on them is just a customer or a product manager or someone like that validated that the code that you wrote was what they expected, right? It's usually a manual thing. You either did it or you didn't. You met expectations, and that's make it work. That's where tech debt lives, right there. I won't make you raise hands, but I imagine that some code that you've worked with has been in the just the make it work section, right? Maybe some code that you've actually written. What's that? Okay. Yeah, depending on where you work, maybe more of it's down there. And that's why it's at the bottom of the pyramid. Going up the pyramid is make it right. And this is kind of where I shoot for. This is production quality. It's maintainable. It's discoverable. So when you're thinking about unit tests, and when I was talking about unit tests, how it changed how I wrote code, it took my 300 line function, and now maybe I have 20 functions that are like 10 lines or 15 lines or something. It's much more easier to grok what that little bit of code is than trying to grok that entire thing that's just doing everything, right? So by writing unit and integration tests, it almost automatically makes your code more maintainable and more discoverable, and it pushes you up into now you're making it right. You're adhering to a single responsibility principle or whatever other patterns that you and the people you work with really care about, starting to get some of those patterns in play. And you're also monitoring for uptime. So, you're starting to look at, okay, I need to go 3 nines, 4 nines, 5 nines, or whatever. When you can actually say, I'm going to go 5 nines and actually meet it, you're probably in make it right. If you're only to make it work, that's going to be hard because you're going to push code. Just, like I was talking about before, push code had that ambiguous column problem. Okay, we're not at 5 nines anymore, right? We just have some downtime. So, and then make it fast is kind of the pinnacle here. It's the highest quality. You're writing benchmark tests, you're monitoring for speed and scalability, and you're doing something about it. The really cool thing, though, is you don't have to write it once, make it work, and then you don't have to refactor it to make it right. You don't have to refactor it again to make it fast. If you start learning how to do these patterns and do that, you can kind of just start at the make it fast, right? You just get to a point where that's just how you write code. And so the speed and your quality are just kind of there, right? And so that's this code quality evolution triangle. That any thoughts or questions on that? Cool. All right. So when I was working at Newbie, there's this other guy named BJ Nelson. Anyone know BJ by chance? Super good engineer. I learned a ton from him. David and I were on a team for a little while, and we're just working away, and all of a sudden I hear him just he raises his hands. He's like, "Who wrote this crappy code?" He's like, just pissed off, right? And we're just like, we just ignore him, because we just keep typing away. And then a few minutes later, he's like, "Oh, that was me," right? And it was code he wrote 3 months ago and he forgot, right? I don't know. Has that happened to any of you guys where you're just like, "Oh, crap, I don't know what I was thinking 3 months ago," right? Testing gives me confidence, right? Testing, I know that my code works. I have confidence to go and change somebody else's code because I know I'm not going to break something that I'm not familiar with. And I'm going to protect myself from code I wrote 3 months ago. And this right here, this is how I've gotten every promotion and every job. By having confidence between the people that get the job and the people that don't. The people that get the job are going to or the people that have confidence are going to get that job more often than the people that don't. If you come in, you're wishy-washy, and you're not quite, they're going to be like, okay, he might know what he's talking about, or she might know what she's talking about, but there's this other guy that just knows, right? I'm gonna pick them. And so this right here, by writing tests, it gives me that confidence. It makes it so I know that when I'm shipping code, I'm not gonna cause downtime. I've tested everything, and if I do, I can go write another test. I can fix that edge case, and then it's gonna gradually or maybe even faster than that. It's gonna get better and better, and I'm gonna get to those 4 nines or 5 nines, right? Because my code works, and I know it. By having that confidence around your work or whatever, you're going to be seen as the expert because you write stuff that is better. The quality is there, right? So testing, writing tests, being diligent about it, making it part of my day-to-day, hitting that go test or whatever language that you guys write in, hitting that all day long, that's going to result in this for you. If you don't write tests diligently today, I want to challenge you to try and write a unit test sometime in your next sprint, right? When you get to that point and you know how it works, you've done one, try and commit to not approving any pull requests without having at least one test in there. It's a very low bar, right? Because you're just trying to do one, you're not testing everything. Just do one for each unit test. That's step 2. And then just keep going. Just continue until one day you're like, I can't believe I ever wrote code without doing this. That was me 10 years ago, right? I can't believe I ever wrote code without writing a unit test. It's so much better and so much faster for me to do it this way than just hitting F5. And then once you're to that point, I'd love to see you guys sitting in front of a group like this and mentoring other people, or mentor the people at your jobs and teach them how writing good unit tests literally change everything for you. Change the way you code and the way you perceive this career. So, cool. Well, that's all I've got for the slideshow. I do have a little bit of code samples. How are we feeling? Are we good? You want to see some code? Yes, no. Got some yeses. Excellent. All right. Let me switch screens here. Actually, I might just do, we'll just, since I'm already sharing this, I'll just show you it this way. So this is a Ruby app. Can you guys read that okay, especially in the back? Okay. This is a Ruby app. What it does is it pulls data from Kafka. It pulls messages from Kafka. It does the transform and it puts it back onto Kafka. It's basically like a Logstash, if you guys have ever used Logstash. But that was its purpose, was to do the T in a streaming ETL. This happens to all be Ruby. It can be written in any language. There are really 2 concepts to understand with this app. There's a pipeline and there's a processor, okay? A pipeline, I'll show you first. By the way, the reason why I chose Ruby, I don't know, you guys are probably mostly do Python. So the reason why I chose Ruby on this project was this happens to be JRuby, the Java version of Ruby. Kafka is written in Java. By using Kafka's Java driver, it made it simpler for me to deal with. And I already knew Ruby, so that's why I chose Ruby for this particular one. Okay, so let me get there. Okay, so a pipeline is essentially just a list of processors that does something. So it's going to pull a message off. We were specifically pulling Debezium messages. Anyone familiar with Debezium by chance? A few people. You haven't used it. Okay. So you're familiar? Is everyone familiar with like Postgres, MySQL? You're familiar with the wall that it writes, the write-ahead log? Debezium reads the write-ahead log, and then it puts it on the Kafka. That's really all it does. It puts on a very specific format. I didn't like their format, so I changed it once it got to this step. I'll show you in a sec. But what I'm doing is I'm pulling change data capture stuff from Postgres, and then I'm doing stuff to it, and then I'm putting it back onto a new Kafka topic. And then the next downstream app in the pipeline was just taking that and putting it into its destination, it was into a data lake. So this pipeline, it basically, it's this the config down there is every pipeline. It kind of works as a middleware, so I can just put all the different processors that I want, that I need to be able to do for that specific pipeline. So I can pull ones out, I can put other ones in there, and it becomes very, very flexible for the things that I want to do, right? So I want to show you that, but the more important piece is these different processors. So I'll show you this coerce one, because that's one of the little bit more complicated ones. Coerce is basically taking the Debezium format and it's flattening it. It's putting it into a format that I wanted it to be in. They do a before and an after in a JSON string. I didn't like that. I just wanted to have one string so I didn't have to worry about the two. So it's basically just taking that and flattening it. That's coerce, right? The way all these work is, so in Ruby, it's an object-oriented language. Everything's inheriting from the command object. And the command object, basically all it is a class variable or a class method that is this call. So you can do like coerce.call and pass in stuff, and it just automatically creates an object, and whatever you're passing in gets set here. And then the process batch is what actually does stuff. So just looping over things, it's changing what I need it to change. And so it becomes these very bite-sized building blocks. You can think of them as Legos or something. And so depending on anything that I need to be able to do, maybe I need to anonymize data. Maybe I need to generate a UUID, right? Maybe I need to do some other things. Maybe I need to publish, you know, whatever I'm going to do, I'm going to create one of these. And because now it's a very small thing, it's very unit testable, right? I already know the format that's coming in. I know what that JSON is going to look like. I know what it should look like in the end. It becomes very unit testable. I don't need to connect to Kafka for this. I don't need to, if all I care about is that, did I take one format and convert it to another format? It becomes really easy to unit test, right? Does that make sense? So let's see, where are my tests? So if we look in here and we look at some unit tests, you can see that, let's see. So here's my pipeline that I'm passing. And then I'm just running. Well, this is actually kind of let me find a little bit more. Okay, so I'm setting up some stuff here. I have a batch that I mocked out. So I'm just pulling this in, and this is my message that I would pull in. And I'm putting that into a variable, and then I just run tests against it. Here's my expected value. So here's my expected. I'm going to check something. Do they equal? If they do, great, my thing works, right? Incredibly powerful 4 lines of code, right? My thing works. I know it works. I know it's going to work in the future, right? And once I know all my building blocks are going to work, I really don't need to write an integration test. I could. I don't actually have an integration test written for this. I have some basic things I'm checking against. Is my Kafka topic what I expect? Because there's some conventions I'm using to know exactly what my Kafka topic could be, or I could just set it. But so there's a couple things there, but I don't really need to test that Kafka's working, because if Kafka's not working, nothing's working, right? And so I don't really even need to write that test. What I do care about, though, is the business logic of this app, and that's back where the processors are. This one happens to be that I'm doing something with the last modified column, right? Does that work? Yes or no? And that's it. This is an incredibly powerful app. It's very simple because of how how it's broken out, but we are handling thousands of messages a second doing this with a single pod in Kubernetes, right? And it's really very little lines of code, but it did what we needed it to, and by having the unit test there, that's why, right? So yeah. Yeah, so if you wanted to make sure that you're testing that Kafka is working, you're testing that it's actually flowing to another queue or another topic in Kafka. If you wanted to test all that kind of stuff, that'd be where you'd write an integration test. And you absolutely could. I could have done that on here where I'm actually, in my Docker, I'm spinning up Kafka. I'm actually sending a message there, and I'm making sure that it goes through, right? That's where you'd write an integration test for this app. If it was a different app, like if you're touching a database, the integration test would be actually running the query. But in this app, it'd be the only thing that I'm integrating with is Kafka, and so that would be the thing that I would want to test. Yeah. Yes. So this is structured as a. It's not actually a Rails app. But I pulled in some of the Rails packages, and that just gives me some magic around like how to include all the files into a thing. And so in my console, I would just run, I think it's Rails test. It's been a little while since I've looked at this code, but I would just run Rails test, and it is. So you got this test helper stuff, but it basically knows to go in, has to be in a folder called test, so it knows how to go into that folder, and so there's a little bit of convention in that. But yeah, you just run Rails test on that, and then it would, or yeah, you could do either rake test or Rails test. They would both work, and that would know how to go into this particular folder. And then just when you do that, you can pass in variables. So you can only test stuff in your integrations. Only test in a different folder if you want, or you can test everything, right? So there's different options that you can pass. And that's actually one thing that you want, whatever language you're using and whatever framework you're using, knowing how that works is going to be, it's going to be to your benefit. Because like I said, a few slides ago, when you get to the point where you're running thousands of tests, it will get to the point where it's lagging for you. Maybe it's taking 5 seconds to run 5,000 unit tests or whatever. So you'd want to be able to segment that down to a smaller portion, maybe just the test that you actually care about, or that folder, or whatever. So, sorry, I should have grabbed some water. Anyway, yeah, does that answer your question? Awesome. Any other? Yeah. In Ruby, yeah, you would let me go back. Let me go back to the right. So it looks at prepending tests in Ruby for mini test. That's the same with I think in Go. In Go, do they do test first? I'm drawing a blank.
Capital T.
Yeah, capital T in Go. So there's a convention there. It knows to run setup before, and there's a thank you, and there's a teardown that runs after. So you can do things like an integration test. You could set up, you could insert a row or something all in one transaction, and then you could run tests against it, and then in your teardown you could roll back that, so you're not actually inserting that data. And that way you can run tests in parallel, and your tests aren't clobbering each other. That's something that's done really well with Elixir. That's Elixir. Phoenix is the framework for Elixir, and they've done a fantastic job with that, where they can they do everything in a transaction, and they roll back every test. And so it's highly concurrent and very fast to run integration tests with them. Still going to take longer than unit tests, but it's pretty good. So Their ORM is called Ecto. If anyone's curious to look further into that one, but cool. Any other questions or thoughts? Did I answer your question? Awesome. Excellent. Well, that's what I have tonight for you. Thanks for coming. Appreciate it.